Hello students, welcome to IMS Academy GATE Foundation course on Network Theory subject. So today we are going to start the session regarding Network Theory subject, which is part 6 of Network Elements, right? Whoever attending very first time regarding Network Theory subject foundation course, you people can visit our YouTube channel, IMS GATE Academy YouTube channel, and then you can just see the playlist regarding the foundation course on Network Theory subject. So in that you can watch the previous 5 sessions which we have conducted earlier. Okay, right? So all of you like and subscribe, all of you like and share this video link with all of your friends. Whoever attending very first time, whoever visiting our YouTube channel very first time, you people can click on the subscribe button and then click on the bell icon so that you will be getting instant notifications whenever we are conducting the upcoming live sessions. You won't miss even single session, right? So this particular subject is common for 3 branches: EC, electrical and instrumentation. Yeah, good evening Matan. So this particular subject is common for 3 branches: EC, electrical and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session, right? So before going to start today's session, I am going to give 2 important updates. Okay, after that I will be starting today's session. Okay. So the first update is regarding our Telegram channel. So regarding our Telegram channel, link is already provided in the description of this particular video. Whoever not yet joined till now regarding our Telegram channel, so kindly join in your free time, right? So whoever joining our Telegram channel, what are the benefits they are going to get? Okay, say for example, currently one live session is happening, right, in our YouTube channel. Similarly, whenever the upcoming live sessions are happening, you will be getting the updates regarding the live sessions and whatever the faculties are writing on the digital board during the live class. Okay, this particular notes we will be sharing in the PDF form. Okay, that PDF we will be sharing in this particular group. Okay, and you will be getting the important updates whenever we are conducting the seminar or webinar, and even you will be getting the important updates regarding government job notifications as well, right? On daily basis, our faculties will provide one quiz question, so all you people can actually participate in that quiz question, and then you can cross check your answer key whether it is correct or not. The very next day our faculty will provide the detailed solution for the question which we have posted for the previous day. Okay, in that way, suppose if you got your answer is wrong, you can cross check while you are going through the explanation or solution provided by our faculty. In that way, you are getting one opportunity on daily basis. You are learning one quiz question on daily basis, right? So it is very much important for all the aspirants who are preparing for the GATE exam, and even like whoever currently studying BTech, even for them also it is very much helpful, whoever writing other competitive exams as well. Okay, right. I hope all of you will share this valuable information with all of your friends because it is free for everyone, right? Anyone can join our Telegram channel. Okay, right. And one more important update. So here at our IMS GATE Academy, we are having the live online program for the GATE aspirants who are targeting for 25 or 26. Okay, right. So all these are the important features regarding our live online program. Whoever interested, okay, you people can click on, you can call to any of these 2 numbers and our counselors will discuss, okay, will clarify all your doubts regarding our live online program which we are offering at our IMS GATE Academy. For the time being, I am discussing regarding the features in brief. Okay. So whoever enrolling for live online program, all the students will be getting 800 plus hours of live online classes. During those live online classes, our faculties will discuss each and every concept from the basic level to the application level, right? And for every concept, we will be discussing the practice questions, GATE questions as well. Okay, so in that way, from the classes itself, all the students are getting the maximum benefit. Okay, and they will be getting the clear-cut understanding with respect to the concept and with respect to the method of solving. Okay, and in addition to that, for all the enrolled students, we are providing, for every subject, we are providing the theory book and then we are providing the exercise book as well, right? So all the exercise books with respect to your branch, overall you are having 4,000 plus practice questions, right? In every chapter, you can find there are 3 levels of questions like level 1, level 2, level 3, right? Whoever able to solve these questions from our exercise book, they can check their confidence, and whatever they have learned the concepts during the classes, okay, while they're practicing the exercise book, they can check their confidence level and what extra they need to prepare, or on which concepts they need to focus more, etc. They are getting the idea. With that, they can do the revision of the classroom notes once again. Okay, in that way, the maximum benefit, all our students are getting the benefit from our exercise book. In addition to that, here at our IMS Gate Academy, we are providing one unique book, one special book, that is 34 plus years gate question bank. Okay, this is one of the special book that we are offering at our IMS Gate Academy for all the enrolled students, right? So all our enrolled students are getting the opportunity after attending the classes, after practicing the exercise book questions, they can go through the previous gate questions of the respective subject and they can practice the questions. And here, based on the possibility, wherever required, we have provided more than one solution as well. And even for the typical questions, we have provided the video solutions. Okay, so you can find the QR code in the solution section. Just you have to open the QR scanner in your mobile, and then the respective video solution will be played. In that way, you are getting the maximum benefit. You are getting amazing learning experience with our gate question bank. Okay, in addition to that, we are providing 130 plus various tests. Okay, all these tests will be in the online, right? For every chapter, one chapter test will be there. For every subject, we are having basic test and then advanced test, and then even we are having multi-subject test as well. Okay, and after practicing those tests, here we are providing all the mock tests as well, right? So all the students who are attending the live classes and practicing the exercise book questions and then practicing the gate PYQs, and then these tests will help you in order to check your real performance. Okay, and in addition to that, here at our IMS Gate Academy, we are providing 12 My Plan sessions for all the enrolled students, right? So that means on an average, in every month, all the students, they can book one My Plan session with the corresponding mentor, and they can get the proper guidance and study plan. If they are facing any challenge regarding their gate preparation, they can discuss their challenges with the corresponding mentor, and our mentors will guide them in one-to-one. Okay, in one-to-one sessions. These sessions will happen in the online, and whoever, okay, so all the enrolled students, they can get the maximum benefit. So in this way, like at any point of time, if any student is facing any challenge, here all our faculties are giving the complete support for all the enrolled students, right? So now it is up to you, whoever having interest to get the very good rank in the upcoming years, right? Now you people can decide, and you can contact to any of these two numbers, and you can enroll for this live online program, right? Okay, I hope whatever the information I have shared, okay, if you are interested or if you are targeting for 25-26, you can enroll. Okay, you can contact to any of these two numbers, or even you can share this valuable information with your friends and juniors, right? Whoever interested, even for them also getting benefited. Okay, right? So I hope all of you will share this valuable information with all of your friends and juniors as well, right? So I hope all of you are eagerly waiting for today's session. So let us start. So in the last class, we have discussed regarding we have started the active elements like sources. Okay, in that we have discussed the voltage sources and current sources. With respect to whatever the sources we have discussed, all the sources are independent, and independent voltage source we have discussed with respect to ideal and then practical. The characteristics we have seen, and then equivalent circuit as well. And then we have discussed the conclusion points regarding the internal resistance as well. And similarly, with respect to current source, independent current source we have discussed regarding, once again, independent current source we have discussed the characteristics with respect to ideal and practical, and then we have discussed the equivalent circuits as well, and then the conclusion points with respect to internal resistance as well we have discussed. Okay, we have discussed in detail about the independent sources in the last class. So in this particular session, we are going to discuss the next topic, that is dependent sources. Okay, so all of you put the heading dependent sources. Dependent sources, or other name is controlled sources. Dependent sources or controlled sources. Okay, so since we are having two basic electrical quantities, one is voltage, another one is current, right? So one is voltage, accordingly we are having two types of sources, one is voltage source, another one is current source, okay. And here we have mentioned the word dependent, right. So the output, whatever the source we are considering, that source can be either voltage source or that source can be current source, okay. In the similar way, since we have mentioned the word dependent, it can depend on some other voltage or it can depend on some other current. So in that way, now can you guess total how many sources, how many dependent sources we are having? Any guess? I have given already hint. With respect to sources, I have given the hint. With respect to dependent quantity also, I have given the hint. Now with respect to that, total how many dependent sources we are having? All you people can mention in the chart. Total how many dependent sources we are having? Yes, obviously you will be getting 4, okay, because we are having two types of source, one is voltage source, another one is current source, right. That voltage source or current source, it can depend on voltage or it can depend on current, right. So accordingly we will be having total 4 dependent sources. We'll discuss one by one. The first one is voltage dependent voltage source, okay. Voltage dependent voltage source, in short you can write VDVS, or other name is voltage controlled voltage source, in short you can write as VCVS, okay. So since we are mentioning the source as voltage, okay, obviously voltage we will represent with polarities, right. We will represent with polarities. So here I am using the polarities plus minus, right. And since it is a dependent source, we will be represent with the symbol diamond or rhombus, okay. So this symbol indicates, okay, in the last class if you observe what are the voltage source or current source we have discussed, I have represented with the circle, okay. Whenever the circle symbol is there, that indicates independent. Whenever the diamond symbol or rhombus symbol is there, it indicates dependent source, okay. Now here output you are getting voltage, okay. Whenever you are having voltage source, that means polarities you will be having plus minus, okay. Similarly here you are having one more voltage source. So since it is voltage source, once again I am representing polarities plus minus, okay. Now here you can observe we have mentioned it is depending on the voltage, okay. So what are the voltage source value here you are getting, that depends on other voltage, okay. For the timing I am considering like K1 into V1. Here K1 is some constant, and that here whatever the output voltage you are getting, okay. Suppose if you, just for easy understanding, I am considering like V0, okay. V0 equal to K1 into V1. Here V1 is nothing but one voltage in the given circuit. Across some particular element you are having voltage, so that voltage is nothing but V1. That voltage when you multiply with K1, so that whatever the voltage you are getting, that voltage is nothing but here output voltage, like that, okay. Similarly you can observe here we are having current dependent voltage source or current controlled voltage source, right. So here whenever you are having this polarities plus minus, that means it indicates voltage source. So here also I am considering like output voltage V0, okay. But in this case it depends on current, okay. For the timing I am labeling some other constant like K2 and the current I2, okay. So I2 is the current flowing through some element in the given circuit, okay. Whatever that current is there, multiply with some constant, accordingly you are getting voltage. So here I have considered for generalized case some constant, but it can have that constant value can be 1, constant value can be 0.5 or 2, etc. According to the requirement and application you may be getting. But here understanding is what? Output you are getting voltage, but it depends on current. Whereas in the previous case, output you are getting voltage, but it depends on other voltage, like that. So in this way, don't get any confusion. Whether it is voltage source or current source, clear cut idea. Okay, whenever polarities are there, plus minus, damn sure it will indicate voltage source. Okay, the symbol, diamond symbol or rhombus symbol indicates it is a dependent source. Okay, and with respect to here, whatever the quantity or parameter you are having, accordingly from there you will be coming to know whether it depends on voltage or whether it depends on current. I hope all of you are getting the clarity regarding the difference between voltage dependent voltage source and the current dependent voltage source. Okay, so with this understanding, now let us move on to the other two sources. So other two sources, obviously current source. Okay, in one case it depends on voltage, in another case it depends on current. Okay, so since we have mentioned it is a current source, how we used to represent in general? Any guess? Current source, how we have to represent? All of you just give a try. Yeah, since it is a dependent source, I have considered the rhombus symbol or diamond symbol. Okay, since we are mentioning it is a current source means we will represent the arrow or direction of the current. Okay, so whenever the arrow symbol is there, that indicates current source. Here also I am representing the arrow symbol which indicates current source. That's all. Okay, now since we are telling that it is a current source, so output I am representing like I naught. Similarly here I am representing output current as I naught. Okay, but in this case, whatever the current value output you are getting, that output current depends on some other voltage. Okay, so for the timing I am labeling as K3 into V3. Okay, here V3 is the voltage across some element in the given circuit. Okay, based on that voltage multiplied by some scaling factor, accordingly you are getting the output current. Okay, similarly here current dependent current source. Okay, here output is current but it depends on some other current that flowing through the some element in the given circuit. Okay, in this way we are having the classification. 4 types we are having. Okay, now all of you just give a try. Okay, I hope all of you understood the terminology with respect to the dependent sources and the representation and corresponding notation, everything. Okay, now all of you give a try. Whatever the, like, whoever from EC branch, you might be having one subject, basic subject of electronics, that is EDC, and whoever from EC electrical IN, of course you will be having one common subject for all the 3 branches regarding electronics, that is analog circuit. Okay, so just try to recall whatever the in analog circuit subject you might have studied various electronic components. Just try to identify one electronic component, okay, which come under this category. Here output should be voltage and input also should be voltage. Like that, just give one electronic component that you have studied from your analog circuit subject. Yes, see, I hope all of you might have studied op-amps, right, during your BTech. Okay, so op-amp we can consider as an example. Op-amp is having 2 input terminals and 1 output terminal, right? So here output I am considering voltage across the output terminal, right? V0 equal to A into Vd. So you are having non-inverting terminal and inverting terminal. The difference between those 2 terminal voltage is nothing but Vd. So output you are getting voltage, it is nothing but the gain into the differential voltage, right? So you can correlate here, output you are getting constant voltage V0, okay, but that depends on some other voltage. That's why here you can consider op-amp is an example of voltage dependent voltage source. Voltage dependent voltage source. Okay, right. Okay, we'll discuss regarding this one in some time. So now regarding this particular category, try to recall one electronic component, okay, which is an example of this particular category. Here output should be current, but it depends on some other voltage. Any guess? Yeah, you might have studied JFET or MOSFET, right? So JFET and MOSFET will come under the examples for this category. So you might have studied regarding the drain current, okay, Kn mu n Cx into W by L into Vgs minus Vt whole square by 2, okay, or similar formula, similar pattern you will be getting another, okay, for same drain current based on the region that you are operating, okay. So whatever the constant term here you are having, I am considering like some constant K, like Kn mu n Cx into W by L, okay, that entire term I have considered like some constant K into Vgs minus Vt whole square. That divided by 2 also I have considered together as a constant, because 1 by 2 is also constant, right? So now you can observe here output you are getting current, okay, but here, yeah, just 1 second. So Vgs minus Vt whole square. Now you can observe output you are getting current, but that depends on, here Vt is like threshold voltage or cut-in voltage, okay. Here Vgs is nothing but the voltage present between the gate and source terminals of that particular MOSFET, right. So here you can observe output you are getting current, but it is a function of voltage, So now you can consider it is an example of current voltage dependent current source. Okay, I have given 2 electronic components, whatever the 4 categories we have discussed, among which, okay, 2 electronic components we have mapped to the respective, okay, according to the respective category we have mapped. Now with this understanding, I hope all of you can answer regarding this particular category. Just recall one electronic component which we can give as an example for this category. I hope all of you can answer. Whoever might have studied from EDC or analog, okay, either you are from EC electrical IN, all the people can answer, because in general in your BTech first year when you are studying the basic electronics or electronic devices and circuits, generally you are studying this one electronic component, okay. When you are studying or about the transistors, okay, I have already given the hint, now you can just recall, that's all. It is very simple. Yes, BJT. BJT is an example of this category. Okay, BJT we can operate in various modes like common emitter, common collector, common base, etc. Right. So here you are getting one of the equation like this, IC equal to beta into IB. IC equal to beta into IB. Right. So here collector terminal is the output, base terminal is the input, emitter is the common for both the input and output, right. So here in this case output you are getting current, but it depends on some other current. So that means BJT is an example of current dependent current source, right. In this way, whatever the electronic components you might have studied, we can category or we can map into the respective source. Okay, so that means in the network theory subject, we are just trying to understand what are the various dependent sources we are having, but the real application or what are the notations here we have considered, like these symbols or notation you are using in the analog circuit subject or in the EDC subject when you are drawing the equivalent circuits. Okay, right. Now I have given the examples with respect to every category, but for one category I have kept pause. Okay, so regarding this category, you people can give a try, and whatever the electronic component you feel is an example for this category, you people can mention in the comment section. Okay, so for the timing I'm keeping as a suspense, right? Whatever the example, whatever the electronic component you feel is an example for this category, you people can mention in the comment section. Okay, for the time being, for all the 4 categories, okay, for all the 4 dependent sources, okay, so especially when you're studying in the analog circuit subject, so one of the chapter will be there like feedback amplifiers. So there you might be studying all the 4 types of amplifiers, right? With respect to input and with respect to output, how you are connecting. The amplifier is one of the block, and then feedback network is one of the block, and these 2 blocks you are connecting with the help of feedback mechanism. The way how you are connecting, like series or series parallel or parallel series, parallel etc. From there, whatever the 4 types of amplifiers, feedback amplifiers that you are learning, okay, those feedback amplifiers now we can map to each category one by one. Now you can observe here output you are getting voltage and input is voltage. So when you are taking the ratio of output and input, both are voltages, right? So that means you are getting the ratio of output voltage and input voltage, that is nothing but gain. That gain is nothing but voltage gain. So accordingly you are getting one amplifier that is called voltage gain amplifier. Okay, voltage gain amplifier. Voltage gain amplifier, right? So with this understanding, all of you give a try for the last case for this category. Here output is current, input also current. When you take the ratio, you are getting current gain, right? So that particular amplifier name is current gain amplifier. Current gain amplifier. Okay, so with this understanding, all of you give a try for this category. See here, output is what? Voltage. Input is current. When you take the ratio, voltage by current is nothing but resistance. Okay, so the name of this one is trans resistance amplifier. Trans resistance amplifier. Okay, so with this understanding, now we can easily answer for this category. Here output is current, input is voltage. When you take the ratio of current and voltage, that is the reciprocal of resistance, that is nothing but conductance. So accordingly we are getting trans conductance amplifier. Okay, so in this way we are having like whatever the 4 types of feedback amplifiers you might have studied, like voltage gain amplifier, current gain amplifier, trans resistance amplifier or trans conductance amplifier, we can map to one, like whatever the 4 dependent sources we are having, we can map accordingly, right? So I hope all of you got the glimpse. Whatever we are introducing the terminology, where you are going to have the corresponding applications. Okay, even if you recall our first class of our foundation course regarding network theory subject, even in that particular session I have discussed that whatever the concepts you are learning in the network theory subject, right? So the applications you are going to learn in the analog circuit subject. Okay, right. Now all of you give a try. It is a very easy question which was asked in the GATE EC in the year 2014 in set 4 for 1 mark. Just the moment you have seen the circuit, you can easily identify which option is correct. All of you can mention your answer in the chart. It is very simple question, direct question. You can observe here here you're having, they have given the circuit diagram like this. They're asking identify the circuit shown below, right? So here you're having what symbol? Direction. Whenever direction is there, that means it is a current source. That's all. Whenever direction is there, it indicates current source. Okay, whenever direction is there, it indicates current source. So with respect to that, you are having two choices. Okay, other two choices we can eliminate. See, if you want to select either option A or option D, then in that diamond symbol, you should have the polarities, plus minus. Okay, if you are having plus minus, then we can choose accordingly. Okay, so since it is a diamond symbol, it indicates dependent source. Okay, right. Since you are having current, direction of the current, it can be upward or it can be downward, no problem. Because you are having arrow, so based on that we have to choose the options accordingly which are having current source. Now you can observe here you are having II. Okay, IA is nothing but what? The current flowing in this particular branch, right? So here you are getting current source, but it depends on other current. So that means here it is a current controlled current source. Option C is correct. So option B also we can eliminate. I hope all of you are getting the clarity. Okay, like this equivalent circuits, when you are studying with respect to BJT or MOSFET, okay, when you are drawing the equivalent circuits, you will be getting like this. Okay, so what is the circuit diagram they have given? It is an example of current controlled current source. Output you are getting current. Okay, based on this current direction of the, based on the direction we have able to identify that source is nothing but current source, and based on this particular notation, okay, here A is nothing but gain, okay, current gain, or that value is the constant, but IA is nothing but what? The current that is flowing through this particular input branch. So that means here output depends on other current. So that's why here we have to choose option C. I hope it is clear. Now let us see regarding the sign convention. See, this is very, very important. In the last class, I have kept one point as suspense, right? So that particular point we are going to study now. Say for example, whenever in the given circuit, if only one source is there, either voltage source or current source, okay, and the rest of the elements, either it can be resistors, inductors, capacitors, then definitely whatever the source given in the given circuit, that particular source definitely delivering the power to other network elements present in the given circuit. But in a given circuit, when more than one source is present, it can be multiple voltage sources, or it can be multiple current sources, or it can be combination of voltage source and current source, etc. Whenever multiple sources present in the given circuit, okay, since we are telling up to now the terminology that voltage source or current source, okay, based on that directly you cannot say that whatever the multiple sources present in the given circuit, all the sources are delivering the power. Okay, it may possible in some cases, but it may not possible in other cases. But among the number of sources, definitely one of the source, definitely it is delivering the power. Okay, but which source? And sometimes more than one source can deliver the power. Okay, more than one source can absorb the power also. But which element is delivering the power, which element is absorbing the power, if you want to know, okay, this sign convention will help you. This sign convention will help you. Okay, it is very simple for easy understanding. So first of all, let us consider with respect to source only. Suppose I am considering generalized case, that means independent source I am considering now. But similar, whatever the topic currently we are discussing, even it will applicable with respect to dependent source as well. Okay, so this is the voltage source, and similarly this is the current source. Okay, right. So here plus minus polarities are there, here arrow symbol is there, and I have represented in the circle. Okay, whenever circle is there, it indicates independent source. Now in general, say for example, the voltage source value is V. Okay, and the current flowing in this particular branch like this. Okay, So that means what? From the positive terminal current leaves. If it is like that, then only that particular element is delivering the power. Okay. So here in this case, the amount of power delivered, will be equal to, power is nothing but the product of voltage and current. But whether that power is delivering the power or absorbing the power, that is the most interesting thing and important thing. Okay. How to identify whether it is delivering or absorbing? Based on this sign convention. From the positive terminal, if current leaves, then that particular element is delivering the power, right? So here delivered power is nothing but V into I. Similarly here, we are considering one current source. Okay, I am assuming that the current source value is I. Okay, current source value is I, and here for the timing I am considering the voltage across that particular source is same thing. For example, I am considering same voltage V. Now you can observe, here you are having plus minus polarities with respect to voltage source. Now from the plus sign, the current is leaving. Similarly here, from the plus sign, the current is leaving. That means this particular source is also delivering the power. Same answer. Power delivered equal to V into I. In both the cases. Okay. But instead of that, if you are having opposite way, that means, say for example, voltage source polarity I am considering as it is. But in this case, current I is entering like this. And regarding current source, instead of current direction upward, I am considering downward. Okay, current source direction I have represented downward, and in this case, the voltage across that particular source is V. Now what happened? Just observe. In general, okay, for ease understanding, I am considering the resistor. Whenever you are having the resistor obviously it is absorbing the power. Okay, so we have mentioned in earlier class also, current analogy analogous to just like water. Water always will flow from high level to the low level. In the same way, the current flows from high potential to the low potential, right? So that means, say for example, I am considering the voltage polarities like this. Across the resistor like this. That means here current will flow obviously in this direction. Suppose if I mentioned plus here, minus here, then accordingly current will flow in the opposite way, right? So in this case you can observe, current enters where? Current enters at positive terminal. Now just observe here. Here current leaves from positive terminal. If current enters at positive terminal, that means it is absorbing the power. The same notation you are having here, you can observe. Current enters at positive terminal. That means it is absorbing the power. Similarly here, current direction is like this. And across that current source, you are having the voltage polarities like this, plus minus V. And here when you look at, the current is entering at positive terminal. Current enters positive terminal. So that means these two are examples of absorbing. So even though it may be source, but actually they are absorbing the power. Okay, in this case, the amount of power absorbed is nothing but the, once again, formula wise same. Whatever the voltage is there, whatever the current is there, you have to multiply. For that particular element, how much voltage you are having and how much current is flowing. So just you have to multiply. But whatever the power you are getting, whether it is delivering power or absorbing power, based on the current direction, whether the current leaves from the positive terminal or current enters at positive terminal. If current leaves from positive terminal, it is delivering the power. If current enters at positive terminal, it is absorbing the power. Okay, it is very important. Generally, most of the students used to do the silly mistake whenever they are asking the question regarding the amount of power delivered or amount of power absorbed by any particular source in the given circuit. Okay, now this is the clear-cut idea, so that whoever follow this particular notation, definitely you people can answer the questions correctly, right? I hope it is clear for everyone, but if any of you couldn't understand, or if any of you are facing any challenge regarding this particular convention, whether it is delivering or observing, if you are having still any problem, you can mention in the chat, I will repeat. Okay, but say for example, in these two categories, the power is delivering, but in the exam, intentionally they can ask, instead of how much power delivered by this voltage source or how much power delivered by this current source, instead of that, they can ask how much power absorbed by this particular voltage source or current source. In that case, actually delivered power is what? Positive. Whatever the delivered power you got, just put minus, that's all. Then observed power will be negative. Similarly here, in this case, observed power is positive, but intentionally if they are asking that calculate the amount of power delivered by either this voltage source or current source. Okay, in that case, you have to write the amount of power delivered is, actually observed power is what? Positive. So whatever the power you got, just you have to put minus, that's all. In this way, you can calculate. Just like when we are saying that in this direction 5 ampere current is flowing, in the opposite direction how much current is flowing? Minus 5 ampere. In that same way, if actually the source is delivering the power, that means delivered power will be positive. Similarly, if actually the source is absorbing the power, so observed power will be positive. But in the questions, if they want to make the question somewhat tricky, they can ask ulta. Okay, in this category, if they are asking observed power, it will be negative. In this category, if they are asking delivered power, it will be negative. That's all. That's all. Okay. Now with this understanding, okay, we'll solve some questions. Okay. But before that, I am just giving one dead easy question. Dead easy question. This is a question asked in GATE EE 2009 for 2 marks. It is a dead easy question and you are getting 2 marks just like that. Okay. All of you give a try. Just read the question and observe the circuit and you can choose the correct option. You can, what are the option you feel correct, you can mention in the chart. Yeah, what is the answer? It is very simple. See, you are having the circuit diagram like this, and in this question what they are asking, you can observe you are having 4 choices. In every choice there are 2 values are there, right? So first question is what? For the circuit shown, find out the current flowing through 2 ohm resistor. Here you are having 2 ohm resistor. In this 2 ohm resistor, how much current is flowing? In this 2 ohm resistor, how much current is flowing? That is the question. That is the first part of the question. Okay. So just observe. Here you are having voltage source 4 volts and you are having current source 5 ampere and then you are having resistor 2 ohm. Resistor 2 ohm. Okay. Just observe the circuit, how these 3 elements are connected. How these 3 elements are connected. These 3 elements are connected in parallel. In parallel, which quantity will be same? In parallel, which quantity will be same? Obviously, voltage, right? Since you are having 4 volt here and the polarities are plus minus, accordingly here you are having the same voltage, plus minus 4 volt, and even across this particular current source also same. Okay. So across every element, okay, across every element you are having the same voltage, 4 volt. Now you know the voltage across the resistor and you know the resistor value, and accordingly you can calculate the current. Since you are having plus sign here, the current is entering, right? So voltage divided by current, so 4 by 2, that is nothing but 2 ampere. 2 ampere. Actually, they haven't mentioned the direction of current. Okay, but here if you observe all the choices, they have given positive value. That means actually whatever the value or direction you got here, as per that only they are asking. But if they are more strictly about the direction, then they could have mentioned here. Okay, but in this case 2 ampere current is flowing in this 2 ohm resistor like this. Okay, the moment you are getting 2 ampere, see why I have told this question is dead easy. Actually they have asked 2 parameters to calculate, but the moment you calculate one parameter, with the help of that first parameter itself, you can choose directly the correct option, even though whether you know the answer for the second part of the question or not, irrespective of that. That's why I have told this question is dead easy. Okay, now let us solve the second part of the question. So here what they are asking, identify the changes to be made to double the current through the 2 ohm resistance. Okay, so here in the 2 ohm resistor, actually you are getting 2 ampere, right? So whatever we have got just now, I am representing once again just for understanding. Okay, so here in this case we are having 4 volt, and then here we are getting 2 ampere, right? So in case 1 we got like this. Okay, now what they are asking, the current flowing through the 2 ohm resistor, we have to make it double. See, identify the changes to be made to double the current through the 2 ohm resistance. Okay, so in the 2 ohm resistance just now we got 2 ampere. If we want to make it double, that means 4 ampere should be there. 4 ampere. 2 ampere multiply with 2, that means 4 ampere. So by using Ohm's law, you are getting 4 into 2, that means 8 volts. Okay, so that means here in this case we have to consider the voltage source Vs, we have to consider 8 volt, because current source, see, current source even though you are changing, but that is not making any sense, because in parallel voltage will be same. Because you are having voltage source, if you are considering this Vs value 8 volt, because of that you are getting 4 ampere like this in this particular 2 ohm resistor. Okay, so you can observe here, put Vs equal to 8 volt. Yes, both the like whatever they have given in option B, both the parameters we got. Actually for this question, in order to choose option B, with the help of first parameter you can directly choose, because 2 ampere is there in only one choice. That is the reason. Okay, so I hope all of you understood. This is a dead easy question. But now let us try to understand. See, here you are having in the given circuit, you are having voltage source and then you are having current source. Okay, now let us try to understand. Okay, let us try to analyze for few cases. Okay, whether both the sources are delivering the power or both the sources are absorbing the power, or one source is absorbing the power and one source is delivering the power. Okay, which source is absorbing, which source is delivering, etc. Just in order to get the clear cut idea regarding this particular simple concept, I am considering the same circuit. Okay, we'll analyze in few cases, so that you will never do even single silly mistake while you are attempting these kind of questions in the GATE exam. Okay, so you will be getting clear cut understanding, clear cut idea whether the source is delivering the power or whether the source is absorbing the power. Okay, now see, the power formula is very simple. Power is nothing but the product of voltage and current, but whether it is delivering or absorbing, based on the sign convention which we have discussed just now, based on that we can tell whether it is delivering or absorbing, right? So just observe here in this particular source. Okay, here current source is there 5 ampere. Okay, so 5 ampere is coming like this. Okay, here you can consider this the node. Okay, to this particular node 5 ampere is coming like this, and in this particular branch 2 ampere is leaving. So that means in this particular branch 3 ampere should leave. Yes or no? See, you can observe 5 ampere is entering like this. Okay, the net current 5 ampere should leave in other branches, because only 2 branches connected. So here already 2 ampere you are having, so accordingly 3 ampere should go. Okay, similarly you can observe here in this case, here 5 ampere is same current, 5 ampere is entering to this particular node. Okay, out of which 4 ampere is leaving in this particular node. 4 ampere is leaving in this particular node, okay, or in this particular branch like this. Now obviously 1 ampere is going like this, 1 ampere is going like this. Now just observe, here in this case 3 ampere is coming like this, okay, in this case 1 ampere is coming like this, 1 ampere is coming like this, okay, right. Now just observe. Now regarding this particular voltage source, voltage into current, voltage is 4 volt and current is nothing but 3 ampere, 4 into 3, that is what, 12 watt, okay. Now similarly regarding current source, here voltage is 4 volt and then current is 5 ampere, 4 into 5, that is 20 watt, okay. Similarly with respect to this 2 ohm resistor, so here voltage is same 4 volt, current is 2 ampere, 4 into 2, 8 watt. Now tell me, among these two sources, which source is delivering? Any guess? You are already having the quantities, from there also you can guess. See, obviously 2 ohm resistor, that is absorbing the power because it is a resistor, right? And you are having the polarities plus minus, at positive terminal current enters, so that means it is absorbing, right? Similarly you can observe here, see the way you are having here with respect to resistor, similar way you are having here current enters at positive terminal, similarly here current enters at positive terminal. Since current enters positive terminal, this particular voltage source actually absorbs the power, okay, so this is also absorbing the power. Now you can observe regarding the current source, current leaves from positive terminal, so that means it is delivering the power, So now you can observe, for any given circuit, the total power delivered should be equal to the sum of all the powers absorbed, okay, the sum of all the powers delivered is equal to sum of all the powers absorbed, okay. In this case only 20 watt is delivering, other two are absorbing, so 20 equal to 12 plus 8, okay. So in this particular example, what happened, this particular current source only delivering the power, whereas the other voltage source is actually absorbing the power, just like this particular resistor. Now with this understanding, okay, you can easily try here also. Same, once again I am writing, voltage source power and then current source power and then 2 ohm resistor power. So in this case voltage source value is 8, current is 1 ampere, so 8 into 1, that is 8 watt. Similarly here 8 volts, so all the elements are contained in parallel, voltage same 8. Then in this case current is 5 ampere, 8 into 5, that is 40 watt. Now in this case current is 4 ampere, 8 4s are 32 watt. Now just like the previous question, here since you are having 2 ohm resistor, current enters at positive terminal, it is absorbing, right? Similarly you can observe, just like here regarding this particular voltage source, current enters at positive terminal, so that means it is absorbing the power, whereas here current leaves from positive terminal, that means it is delivering the power. So just like the previous case, here also same. So only current source is delivering the power, whereas the other two elements are absorbing the power. 40 equal to 32 plus 8, that is nothing but 40. Once again it is balancing, right? Now here one case I have considered, in this particular resistor 2 ampere is flowing, in this particular resistor 4 ampere is flowing. Now let us consider one case, in this particular resistor 5 ampere is flowing. Okay, 5 ampere is current is flowing, and one more case, let us consider 6 ampere current is flowing. 6 ampere current is flowing. Okay, now in this case what is happening? 5 ampere current is coming like this, and the entire 5 ampere is flowing like this. That means in this particular branch, any direction you can consider. If you want, you can consider like this, or if you want, you can consider another way, no problem. So accordingly you are getting 0 ampere. Okay, in this direction or in the opposite direction, no problem, because whatever the 5 ampere is coming, the entire 5 ampere is going like this. Okay, in this case 5 ampere is flowing, and 2 ohm resistor, by using Ohm's law, 5 into 2, that is nothing but 10 volts. That means voltage source value we have to consider 10 volts. Voltage source value we have to consider 10 volt. Okay, now in this particular example, 6 ampere into 2 ohm, that means 12 volt. In this example, we have to consider the voltage source value as 12 volt. Okay, now tell me, in this particular circuit, okay, for this example, okay, how much current is flowing in this particular voltage source, and in which direction it is flowing? All of you give it a try. See, you can observe here 5 ampere is entering, and here 6 ampere is leaving. That means, see, if 6 ampere has to leave in this particular branch, in these two branches together 6 ampere should come. But here 5 ampere only coming, so obviously in this particular branch 1 ampere, if it come like this, then 1 ampere, 5 ampere, together 6 ampere is entering, 6 ampere is leaving, right? I hope all of you are getting the clarity. Now in this case, once again let us calculate the powers. Right. So in this particular example, all the elements are contained parallel. In parallel, voltage will be same, that is 10 volt. Okay, in this particular example, the voltage across every element is 12 volt. Okay, now here current flowing is 0 ampere, that means 0 watt. Here current is 5 ampere, 50 watt. Here current flowing is 5 ampere, so once again 50 watt. So here in this question you can observe, since here in this case the current leaves from positive terminal, it is delivering. Okay, here current enters at positive terminal, it is absorbing. Okay, so in this case, since you are getting 0 ampere, okay, you can consider like this, or you can consider in the opposite way, no problem. Whatever 0 watt here you are getting, you can consider like absorbed power is same 0 watt, or even if you want, you can consider delivered power, no problem. Okay, if you are considering the direction like this, that means current leaves from positive terminal, delivering power. If you are considering arrow direction like this, current enters, absorbing. Because minus 0 is nothing but 0. Either plus 0 or minus 0 we can consider as 0. That is the reason whenever you are getting 0 watt, whether they are asking absorbed power or delivered power, the final answer will remain same. But if you are getting absorbed power as 5 watt, that means delivered power should be minus 5 watt, like that. But in this question, okay, in this question you can observe this particular source is delivering the power just like the previous two cases. Okay, this particular resistor is absorbing the power, whereas what is the voltage source here you are having, we can say, because you got 0 watt, we can say that this particular voltage source in this particular example, it is neither delivering the power nor absorbing the power. We can say like that, because you are getting what? 0 watt. Okay. Now let us calculate here regarding the powers. So in this case, 1 ampere current is flowing, that means 12 watt you are getting. In this case, 5 ampere current is flowing, 12 into 5, that is 60 watt. Next, in this particular resistor, 6 ampere current is flowing, 6 12 sir, 72 watt. Okay, now just observe here Obviously this particular resistor is absorbing because current enters at positive terminal, right. Now regarding this current source, current leaves from positive terminal, that means it is delivering the power. Now see the beauty here regarding this particular voltage source. From the positive terminal current leaves, from the positive terminal current leaves. Similarly, just like here, from the positive terminal current leaves, right. So that means this particular source actually now in this case it is delivering, it is delivering. Now you can add these two. Sum of delivering powers, it should be equal to sum of absorbed power. 60 plus 12, that is nothing but 72. 72 is equal to 72, right. So in this particular example, both the sources are delivering the power. Okay. Whatever the examples we have considered here, either first case or second case, actually current source is delivering, the voltage source is absorbing. Okay. In the third case, current source is delivering, but the voltage source is neither delivering nor absorbing. Okay. In this category, both the sources are delivering the power. Okay. Now let us consider one more case just for understanding. I hope all of you got the clarity regarding these four cases, right. Okay. Now I will show for one more case. In that case, I am just changing the current direction. Okay. In all the cases I have considered current direction is upward. Now let us consider, I am considering one case, current direction is downward. Current direction downward I have considered 5 ampere. Okay. Now in this case I am considering in this 2 ohm resistor I am considering 1 ampere current, 1 ampere current, right. So by using Ohm's law you are getting the voltage as 2 volts, 1 into 2 that is nothing but 2. Okay. Now just apply KCL at this particular node. Here 5 ampere is leaving. Okay. Here 1 ampere is leaving. That means from this node in these two branches together current is leaving, right. 5 plus 1 that means 6 ampere is leaving. So obviously here 6 ampere should enter. 6 ampere should enter to this particular node. Then 5 ampere plus 1 ampere together 6 ampere, right. So in this case what is happening? 6 ampere current is leaving from the positive terminal like this. Okay. So here 2 volt. So that means in this case I am considering voltage source value as 2 volt. Okay. So in this particular example, so let us calculate the power across every element. Right. So here all the elements are connected parallel. In parallel voltage will be same. So in this particular example the voltage value is 2. Whereas here current is 6 ampere, 12 watts. Here current is 5 ampere, 10 watts. Here current is 1 ampere, 2 watts. Now, obviously this particular resistor, current enters at positive terminal, it is absorbing, right. Now just observe, just like here, current enters at positive terminal. Similarly here, current direction is downward. That means current enters where? Current enters positive terminal only. Current enters positive terminal, right. So that means since it is entering at positive terminal, it is absorbing, right. Whereas here, from the positive terminal current leaves. That means it is delivering, right. So here sum of absorbed powers, that means 10 plus 2 is nothing but 12, which is equal to the delivered power, right. So in this particular example what happened? Actually this particular voltage source is delivering, whereas current source is absorbing, right. So in this way, whenever multiple sources are present in the given circuit, we should not directly comment that all the sources are actually delivering the power. It need not be. It may be satisfying in few cases, it need not be in other cases, right. So based on the network elements present in the given circuit and based on how much current are flowing in that particular elements or how much voltage you are having or with respect to the polarities, etc., based on other network elements connected in the given circuit, based on that some of the sources can deliver the power, some of the sources can absorb the power, right. I hope all of you got the crystal clear idea and regarding the concept whether the source is delivering the power or whether the source is absorbing the power, right? So for the time being, I'm stopping here. Okay. So I'm giving the next question, which is asked in GATE EC 2009 for 2 marks. This is a simple question, but I'm not discussing this question now. I'm giving as a homework for all of you. Okay, all of you give it a try. We'll discuss this PADI question in the next class. Okay, all of you give it a try. Whichever option you feel correct, you people can mention your answer in the comment section. Regarding this PADI session, regarding this PADI question, we will be discussing on tomorrow's session. Tomorrow we are having one more session regarding network theory subject foundation course, right? In that session, I will be discussing this question first, and then we'll move on to the continuation topic. Okay. So in this PADI session, we have discussed in detail regarding the dependent sources, how to represent, okay, and with respect to the sign convention, whether the source is delivering the power or absorbing the power. With respect to independent sources, we have discussed, even it is equally applicable with respect to dependent source as well, right? We have discussed some questions in this particular session. I have given one homework question. I hope all of you will give it a try, because that is a simple question. I hope all of you can get the correct answer. Okay, I am eagerly waiting. So you are having the time till tomorrow. Okay. So before we are going to start this PADI session, till then you can attempt that PADI question, and whatever the answer you feel correct, you can choose, you can mention your answer in the comment section. Okay. So tomorrow we are having next session regarding network theory foundation course only. So up to today's session, we have discussed in detail about the network elements, like we have started from the types of elements, and then we have discussed with respect to passive elements and then active elements in detail. We have discussed all the basics we have covered. In tomorrow's session, after discussing that homework question, I am going to start the basic laws. Okay. So regarding basic laws, this is the first session, right? So that's why here we have mentioned that basic laws part 1. Okay, we'll meet you all on tomorrow's session, right? So before ending today's session, whatever the 2 updates I have given in the beginning of today's session, once again I'm showing. So the first update is regarding our Telegram channel. So the link is already provided in the description. Whoever not yet joined, so kindly join our Telegram channel. All these benefits you are getting for free of cost. Okay. And one more update regarding the live online program at our IMS Gate Academy, which we are offering for Gate 25-26. Whoever interested, you people can contact to any of these 2 numbers. Our counselors will discuss in detail about our live online program that we are offering at our IMS Gate Academy. It is giving maximum benefit for all the aspirants in the coming GATE exam. Okay, right. So with this, I am concluding for today's session. We'll meet you all in the next session, that is on tomorrow. Thank you everyone.